Okay, so hello everyone. My name is Kunal and I'm your mathematics tutor. And today we are going to start our new chapter, which is application of integral. We already deal with the chapter integrals in which we partially deal with indefinite integral and the definite integral. And now we are going to learn some its real life analysis and its applications. So application of integrals. So today is our lecture number 1. So let's begin with a positive vibe. Okay. So in this chapter, we are using the things that we are already learned in definite and in indefinite integration, and we are exploring the new things like how can we uh, apply this in real life problem or anything. So or we are actually look at more and more uh, perspective view. Okay, so let's begin the chapter. So our first topic is estimation of a function or a definite integral. So let me write here estimation. So estimation of definite integral and general inequality. So this is our first topic in application of integral where we estimate the our डेफिनेट इंटीग्रल समटाइम्स क्या होती है कि जो भी हमें इंटीग्रेट करने को दिया होता है वो उसकी इंटीग्रेशन पॉसिबल नहीं होती है राइट सो व्हाट वी डू वी एस्टिमेट इट्स वैल्यू कि उसकी इंटीग्रेशन क्या होगी राइट सो लेट्स see which type of problem gonna ask in this and how to estimate, right? So let me begin the chapter. So let me write it here for monotonic increasing function. You all know that what is monotonic increasing function. So let me clear here. Increasing function means like dy by dx is strictly positive. And monotonic increasing function means dy by dx greater than is equal to 0. Okay. So let me tell you by graph what is monotonic and what is strictly increasing function. So if your graph certainly look like this, so it is strictly increasing. Like there is value A, there is value AB, this is x-axis, this is y-axis. So it is a strictly increasing function. Okay. And when we talk about like something like that, let me make it in a good way. So if I talking about this is my x-axis, this is my y-axis, and we are talking about like that. This is A, this is C, and this is something B. Okay, so this function is also increasing as x increases. This function value also increases, but when x belong to A to C, its value is constant. Function value is constant, right? So there the graph of the function is dy by dx is equal to 0. And then after in region C to B, in region C to B, its value strictly increases, right? Strictly increases. So in that region, the dy by dx greater than 0. So if we including the whole region like from A to B, when x belonging to A to B, so what we get? Dy by dx greater than is equal to 0. So this is actually the monotonic function graph, and this is the strictly increasing function graph. So this function represent this and this. Okay. So now, so first thing we are dealing with monotonic increasing function. So how to estimate its value? Let me write it here. Okay. So for monotonic, I hope you'll all understand what I'm trying to say about monotonic increasing function. and how its graph something look like. So monotonic increasing function in x belonging to A to B, uh, our estimation is like that. This is our f of A from A to B is greater than is equal to uh, from here actually A to B, f of x is greater than or equal to f of B A to B. So this is our estimation. Look, we are actually increasing, we are actually integrating our function from A to B, right? What we are doing, we are actually integrating our function from A to B. We are integrating our function from A to B. So what I'm trying to say, if we uh, put the lower limit in the function without integrating, so its value is less because dy by dx is greater than is equal to 0. So as x increases, fx increases. That means here, what I'm writing here, so let me tell you, actually ये हुआ कैसे, and then we go through. So let me take in a side. यहाँ पे मैं साइड में आपको समझाता हूँ कैसे हुआ. Look, our x varies from A to B, right? Right. And because our fx is increasing function, monotonic increasing function, monotonic increasing function. So f of x is greater than or equal to f of A, less than or equal to f of B. I hope you'll all understand what I'm trying to say. As x increases, fx also increases, right? So x increases from A to B. So fx increases from fa to fb. I hope you'll all understand this, what I'm trying to say. Okay. So now, uh, if we integrate it from A to B, integrate this function also from A to B, and integrate also this function from A to B, so we get the same thing as we get here. Right. I hope you'll all understand this, what I'm trying to say. Right. I hope you'll all understand this, what I'm trying to say is, right. So let me write it here. I hope you'll all understand this. Like as x is belonging to A to B, and then fx is monotonic increasing. So as x increases, fx increases, so we can write into this form. Equality comes from monotonic word because it's not strictly increasing. Sometimes dy by dx also equal to 0. So the equality comes here uh, due to the word monotonic. So let me write it here now by, I hope you'll all connect this. What I'm trying to say is, okay, now solve this. So what we get here, there is nothing, right? Dx, and fa and fb are constant, right? Fa and fb are constant. I hope you'll all understand is what I'm trying to say. Fa and fb are constant. Now we are just put lower limit in fx, right? We just, fa is not variable, fa is just constant. I hope you'll all understand this. So what I'm writing here, when we integrate this concept, what we get? We get fa x from A to B greater than equal to, there will be like fx dx from A to B, because we don't know the function, so we can't integrate it. But these are constant, so we can take it out and integrate it. So what we get it from here, we get B minus A. I just substituting the limit f of A greater than equal to integration of fx dx from A to B and less than is equal to B minus A f of B. So this is my standard, what it's called, estimation. I'm trying to say, if our function is monotonic increasing function, then the integration of function is lies between B minus A f of A to B minus A f of B. I hope you'll all understand this, what I'm trying to say. Okay. So this is our estimation. So let me show you this by graph. Okay. So for that part, let us suppose this is our x-axis, this is our y-axis, and let me make with some different color. And this is our graph. This is our f of x, right? And let us suppose this is our point, something called A, and this is our point, something called B, right? So what I'm trying to say, this area, this actually represent this area, right? We are integrating f of A because we take that constant. We are integrating f of A, which is constant, from A to B. So this area, and which is, let me now go, this is greater than is equal to, now for that graph, take that as x-axis, this is y-axis. So let me make the graph of fx again. So this is our graph of f of x, and this is our a, x is equal to a, this is our x is equal to b. So our actual area is this, right? We have to calculate this area. I hope you'll all understand this, what I'm trying to say. We have to calculate this area. We have to calculate this area, right? But what I'm doing here, I am just integrating. We are first taking the lower one. So if we integrate f of a with dx, so it will something look uh, like this. And we have to calculate actually this area, what I'm drawing here. Now, it is greater than is equal to. Now, let me draw this part area, like graph. So it's something look like we are actually, we all know that like definite integration geometrical meaning is area only, right? And I just using that to estimate the value of a function or definite integral. So this is our f of x, and there is our a, and there is our b. So what I am doing is actually we are calculating this area. Okay, actually we are calculating this area. Okay, so I hope it's clear to all of you, like what I'm doing here and all. So let me tell you again, actually this is our assumption and this is our estimation, like our integration of function fx from a to b is greater than is equal to this value and less than is equal to this value. We estimate that, and we also proved it by drawing the graph of a function. So we actually look the graph of b minus a f of a, something look like that, the graph of fx dx, which represent, and we also know that the definite integration geometrical meaning is area, basically area. So we deal with the area, we going through the area, and ये clear दिख रहा है कि this area is less than equal to this area is less than equal to this area. So our value lies between b minus a to b minus a fa to b minus a fb. So actually we use these kind of things in problem solving. कभी कभी होता क्या है कि डेफिनेट इंटीग्रेशन सॉल्व नहीं कर पाओगे, because there is a there is a statement, and which is every differentiable function, every function is differentiable, but every integration is not differentiable, but every integral integrand is not integrable, right? This is the statement, this is the very sensitive statement, like you can differentiate each function but you can't integrate each and every single function, right? So you have to use the estimation things. And the first estimation we learned today is for monotonic increasing function in x belonging to A. So our estimation is this, and we proved it as well by drawing the area kind of thing, right? I hope you'll all understand this, what I'm trying to say. Sometimes it is not easy to integrate and calculate the value of a definite integral. So we use the uh, estimation kind of thing. Okay. Now, now for now let's move on to the second case, which is case two. Let me write it here, case one, for this is actually case one. So let me write to the case two for a monotonic decreasing function. We have first seen monotonic increasing function. Now we are actually dealing with the monotonic decreasing function in x belonging to A to B. So our assumption or estimation, our estimation is, let me write it here, then we also deal with it. So our estimation is integration of fx dx from A to B is less than or equal to integration of f of A dx from A to B and greater than or equal to integration of f of B dx from A to B. So this is our estimation. Now, let me tell you the uh, about some monotonic decreasing function. So what is first we have to deal with monotonic decreasing function. So as we know that the monotonic decreasing function means like dy by dx less than is equal to. That means if x increases, f of x decreases, or if x decreases, f of x increases. This is the definition of monotonic decreasing. Dy by dx less than is equal to 0. And if x is increasing, fx is decreasing. And if x is decreasing, fx is increasing. I hope you'll all understand this, what I'm trying to say. So here, and let me prove this thing here. Okay. So here we all know that x varies from okay, not is equal to x varies from A to B, right? As given any question, x varies from A to B. Okay. Now, our f of x varies from FA to FB. Look here, things are varies because as x increases, fx decreases. So our x max value is B, right? So the FB is the minimum value. X increases, fx decreases. So this is our condition, and when we integrate this from A to B, it follows the same trend, right? So f of A to B. I hope you'll all understand this, what I'm trying to say. Okay. Now, let's move on to there. So let's integrate this function. First I actually tell about you the monotonic decreasing function. That means like dy by dx less than or equal to 0. And this equality sign, like here, I missed the equality sign. So this equality sign comes due to the word monotonic, right? This equality sign comes due to the word monotonic. I hope you'll all understand this, what I'm trying to say. Okay. So now, let me integrate this and try to find it out. So when we integrate this, what we get? F of B, because f and fb are constant, I already tell you. So f of B, and there will be like x. Now we have to substitute the limit, and there is like f of x. We are integrating from A to B dx, and there will be again constant f of A, and we are integrating from A to B. So what we get here? We get f of B, and direct inserting the limit, upper limit minus lower limit. And there will be, we don't know the function, so we can't integrate, write it now. So just keep it here. And there will be like b minus a and f of a. This is our estimation, right? This is our estimation. Like how I estimate the value of definite integral. I'm again saying sometimes you can't calculate and can't integrate the function to get its value. So we have to use the estimation things to calculate to get the value near to it. And this is the way, like first case, we are dealing with the monotonic increasing function. If the function is our monotonic increasing, and we all know that how to find it out, if dy by dx greater than equal to 0 and monotonic decreasing function dy by dx less than equal to 0. And certain things I prove it here. So this is our estimation. If our function is monotonic decreasing function, so our value of integral varies from b minus a f of b, where b is the maximum value of x and a is the minimum value of x. So we already write it here, right? Okay. So now on, move on to this some noted point, which is as like if g of x, any function it is, okay, g of x less than is equal to f of x and less than is equal to h of x. These are function of x, right? Um, all x, this is read as for all x belongs to, you all know this symbol, like this symbol represents the belongs to from A to B, okay? And noted thing is here is all fx, gx and hx functions are continuous. This is the first thing that we read in lecture number 1, definite integration. If we have to integrate any function from a certain limit like a to b, the function should be continuous in a to b. Then we can integrate. Otherwise, we have to break the function. We already deal with this thing. Okay, so I'm not going to repeat again it. So now, then this is actually not. So you have to, these are the following property that we follow actually. Then if we integrate this function like g of x from a to b, so it is also greater than, actually less than, is equal to integrating function f of x from a to b, and this function f of x is less than integration of hx from a to b. So this is the things. And if you ask for proof, so I'm again saying, look at this. F of x, we can write like f of x minus g of x is greater than equal to 0, and h of x minus f of x is greater than equal to 0 for all x belongs to a to b, right? So this is actually increasing function. And we all know that monotonic increasing function property, which we already deal with this. So when we follow this trend, we get to the favorable result of this. Okay. Now, now the second noted point. This is also important. If so, these thing actually we are gonna implement in our integrand problem. Okay, so try to learn it very carefully, because this is not easy things to estimate the value of definite integrable. It is sensitive topic. So you have to be careful each and on each and every single step what I'm doing. That's why I am explaining each and everything. Okay, so this is our second noted point, which is something look like if uh, small m and capital M are respectively the least and the greatest value of fx in x belongs to a to b, then first try to understand what this statement tells. So this statement tell you that like f of uh, f of x की जो max value, जो greatest value है, that is b. Now we don't know here. Let me show you. We actually don't know that our function, our fx is monotonic increasing or decreasing. We actually don't know. Okay, let me write it here in a good way. Okay, so we don't know our monotonic function is increasing or decreasing. We don't know. We just know that our function value, our function least value in x belonging to A to B is m small m, and the greatest value in A to B is capital M. But we don't know our function is monotonic increasing or decreasing. Then our estimation is something like our values varies from small m b minus a to, we have to increase like a to b, and f of x dx. This is our function which we are integrating, and this is the capital M b minus a. So what I am using here, we don't know our function is monotonic increasing or decreasing, but we know one thing. Like this is our max value. Fa is the maximum value of the function here for monotonic decreasing case. Look at me here. For monotonic decreasing case, f of a is the maximum value of function. In monotonic increasing case, f of b is the maximum value of function. F of a is the minimum value of function. Here also f of b is the minimum value of the function, and f of a is the maximum value of the function. So if the function is not given that it is monotonic increasing or decreasing, but it's given that its maximum and minimum value. So here in the place of something f of c, where the maxima exists, we directly write the value like f of c is equal to capital M. So we direct write its value. I hope you'll all understand is what I'm trying to say. There, this is the place for function maximum value, and this is the place for function minimum value if you observe from monotonic increasing or decreasing. Look at here, in monotonic decreasing, b minus is there, but this is the function minimum value. This is the function maximum value. Then this is the function max value. This is the function mean value. So same wise, there is the function maximum value, which is capital M, and there is the function minimum value, which is small m. Okay. So I hope you'll all understand this, what I'm trying to say. So let's move on to the some problem, right? So how to implement these things that we are learn there. Okay. Okay. Or let me show you this by, if you have any doubt, like, so let me show you this by graph. कभी भी estimation में कोई भी doubt आ रहा हो, make it graph. Everything is clear to you, right? So let me make it graph. What it's representing. So let us suppose that this is our x-axis, this is our y-axis, and this is our something our graph look like, not a sharp. Okay, so something our graph look like. Okay, and let us suppose there is our x is equal to a, and there is our x is equal to b, and this is our actually function minimum value. So this is small m, and actually this is our function max value, right? So this is, okay, so this is capital M, right? In x belonging to A to B, not at x is equal to A, its minimum value. There in this case, okay, let me change here. Okay, so that's why, otherwise you are on a thing. Let me write A is here, then it is 1. Okay, so let's suppose this is x is equal to A, and there is the x is equal to B. So in this region, from x is equal to A to B, our function minimum value is at something some x, which is small m. This is the minimum value of the function because इससे बड़ा ही सब है. And the function max value is at some x, which is value is capital M. Right. Now, what we have to calculate? We have to calculate this. Let me show you. Actually, we have to calculate this area. Right. This is actually our f of x dx. Right. This is our f of x dx. But what I'm doing it here, let me use it another color. We are actually first integrating. Let me extend it. We are integrating this area. This is the lowest area. And let me use the some other color for better understanding of your. I'll take the dark color and using this area for violet represent the upper estimation and red represent the lower estimation, actually lower value estimation value, and green color represent the actual value, right? So our value, which is in green color, is lies between red and the violet. So the violet is the region of the graph which so the violet region represent the upper value estimation and the red value and the red zone represent the lower value estimation and the green is our actual value. So it lies between this. So actually this is the graphical approach to understand the following thing. Okay. So now on, let's take an example on it and then try to find it out. So take an example. So our example number one, one more noted point to go to example. So let me write it here. So there's another noted point which is actually this is noted. We are integrating f of from a to b, f of x dx is less than is equal to, we are integrating f a to b, f of x. We already know that, right? The mod one. We actually did this thing in lecture number 1 or 2 of definite integration. I'm not clearly remember, but yeah, this is the thing that we learned. So यहाँ पे noted point ये भी है कि equality hold when f of x is entirely of same sign in A to B. Equality hold when f of x is entirely of same sign in A to B. Okay. So this is the thing. Now, let's take an example. One. Okay. So our example is something look like we are integrating from 0 to 2 pi mod of sine of x dx. So, okay. So you have to not solve this. You have to estimate and you have to estimate its value and then verify. This is the actually question. What you have to do? You have to first estimate its value, किसकी value क्या होगी, and then you have to calculate its value and then verify कि is it your estimation is right or wrong. Okay, so this is the question. So try to do it yourself by pausing the video. Otherwise, let me solve, right? So we know that like integration of a to b f of x dx is less than is equal to mod of f of x dx from a to b. So we are using this estimation. So we can write this as mod of sine of x dx and we are integrating from 0 to 2 pi. right? Okay. And we know that the period of the function sin x is mod of sin x is pi. So here is the function like 0 to antiform. We already read this. Remember the fourth property A part, right? Fourth property A part of definite integration. So this is of the form, its period is pi. So we can write this function as n times 0 to t fx dx. So let me write it here. 2 times 0 to pi sine of x dx, mod sine of x dx. And we all know that the graph of sine x is something look like that. In 0 to pi, its value is positive. So we can take it from positive sign. So 2 into 0 to pi, it's open with the positive sign. And we know that the integration of sine x is minus cos x. So it will be like minus of cos x 2 times, which is 0 to pi. So what is the value of uh, cos pi? It will be minus 1, right? So minus 1 into minus 1, that will be 1. And the value of cos 0 is 1, so it will be 1. So it will be, its value is. So first you have to write our estimation is like if we are integrating a function from 0 to 2 pi sine of x dx, its value is less than or equal to 4. Let me write it here in a good way so that you can understand what I done here. Sine of x dx, we are integrating this from 0 to 2 pi, and this value is equal to 4. So we can say that our estimation is the value of this integration is less than 4, less than or equal to 4. This is our upper value assumption. Okay. So now what you have to do, now you have to check. So our assumption is the value of integral is less than 4. Okay. Yeah, I have no assumption. Now I have to verify it. So let's verify. Is it our assumption is right or wrong? So when we when we integrate this function from 0 to 2 pi sine of x dx, and then in last we put the mod. So what we get? The integration of sine x is minus of cos x, and we have to put the value 0 to 2 pi and put it mod here. Okay, so when we substitute the upper value, it will be like minus 1. And when we substitute the lower value, it will be like plus 1. And there is the mod, so our value got 0. And mod of 0 is 0. Oh, yes, our estimation is correct. Our estimation is correct because what we get the value of integral. This integral is 0. And what's our assumption is, and estimation is, our estimation is the value of this function must be less than 4, less than or equal to 4. And it's valid, right? And it's valid. Why? Because we get the value of integral as 0. And 0 is less than or equal to 4. Not equal to, but less than 4. Na? So our assumption is, our estimation is valid or true. I hope you'll all understand this, what I'm trying to say, right? Okay, so let's take the another example and then try to move on. Okay, so now you have to prove. This is actually proof. So this section of application of integral is mostly based on proof. So you have to prove. What you have to prove? You have to prove like 1 is less than is equal to 0 to pi by 2. We are integrating the function which is known as sin x by x dx, and this is less than pi by 2. Look at that. Look at this. One more thing I'm trying to say is some function you can't integrate. So you have to use the things, you have to use the estimation thing. Now I don't know how to integrate the sin x by x. Either you apply the by parts here, if you tell like apply the by parts here. Okay, so according to IIT, but you have to prove like its values vary from 1 x se badi hogi and pi by 2 se choti hogi, which is pi by 2 like 1.57, right? So what we have to find? First we have to find, because listen, यहाँ पे अपन फंक्शन की मैक्स एंड मीन वैल्यू दी नहीं हुई है, यहाँ पे अपनी फंक्शन की मैक्स एंड मीन वैल्यू नहीं दिए हुए. सो व्हाट वी हैव टू डू, फर्स्ट स्टेप वी हैव टू फाइंड दैट इज आवर फंक्शन monotonic increase or decrease, monotonic increase or decrease in x belonging to 0 to pi by 2, because our elementary element varying from 0 to pi by 2, so we have to look like our function is monotonic increasing or decreasing in x belonging to 0 to pi by 2. So this is the thing that we have to learn. Okay, so let's go and try to find it out. So our fx is nothing but sine of x by x. So how do we find we differentiate this? So using the quotient rule. So it will be x square, x cos x minus, okay, and sine x, right? And we are looking in this like all x belongs to 0 to pi by 2. Let me correct here, open the bracket. Okay. So, okay. Now, we have to calculate in this region only. So what I'm trying to do here, take the cos x common. So if we take the cos x common, because we all know that the cos x value is positive and sin x value is also positive in 0 to pi by 2. Because look at the graph of sin x, positive. Look at the graph of cos x, positive. So we can't deal with. So take the cos x outside, basically common. So cos x by x square, and that will be like x minus 10x. Now, there is a situation. We all know that when x is very, very small, tan x is greater than x. But when x increases, tan x is also increases. But look at the value. This term is negative in 0 to pi by 2. That means f dash x is, that means df of x by dx is negative. That means our function is decreasing function. And we know that when our function is decreasing function, look at this case, where it is. Where it is, okay, when our function is decreasing function. So what it is? This, right? So we have to do the same thing here. What we have to do? Our function is decreasing. So f of x dx from 0 to pi by 2 is nothing but b minus a, right? We are actually using this thing. Let me write it here, then I have to apply. So it will be clear to you all. Then our function is decreasing. So what I have to apply? I have to apply like f of x dx. We are integrating from a to b. So value will be less than equal to f of b, right? I mean f of a now, because our function is decreasing. F of a dx from a to b, and it will be greater than equal to f of b dx from a to b. Okay, so let me write it here. So our a value is 0, b value is pi by 2. So like 0 to pi by 2 fx dx. So like 0 to pi by 2 and put the value of whatever it is, like so f of 0 dx, and there will be like f of pi by 2 dx. So there will be like 0 to pi by 2. Now, look at here. We have to find like f of 0 and f of pi by 2. What is our f of x given is? Our f of x given is sin x by x. Okay, so there we have to substitute 0 here. So we have to take limit because it is 0 by 0 form. So sin x by x, and its value is nothing but 1. Then we have to find the x of pi by 2. So it will be like 2 by pi, because let me, because sin pi by 2 is 1 and x value is like pi by 2. So its value is 2 by pi. Now, what we get 2 by pi. We are integrating from 0 to pi by 2 dx less than or equal to, we are integrating from 0 to pi by 2 fx dx. So we are this from like 0 to pi by 2, and this value is nothing but 1. 1 dx, right? So when we integrate this, what we get? We get 2 by pi and x from 0 to pi by 2, 0 to pi by 2 sin x by x dx, and this will be like 1, that means x 0 to pi by 2. And when we insert the limit here, what we get? 2 by pi into pi by 2, 0 to pi by 2 sine of x by x dx less than equal to pi by 2. So finally we get the answer, which is proved. What it is? 1 greater than is equal to sine of x by x integration dx is from 0 to pi by 2, and it is less than equal to pi by. This is proved. Okay. So I hope you'll all understand is what I'm trying to say here. What I use here. First step, to prove it, like we don't know where it is. Okay. The first step is like we don't know our function is monotonic increasing or monotonic decreasing, right? And even we don't know the function maximum value and the minimum value. So first step is to follow like you have to find our function is decreasing or increasing in given x, in given region of x. Our function is increasing or decreasing. So we get like our function is decreasing. Why? Because f dash x is less than 0. That means decreasing. X minus x is negative, right? So it will be decreasing. Now, what we use when we use a case number 2, which is based on when our function is decreasing function. So what we do, we are actually follow this estimation, and I use this estimation because we already proved it as well, right? Proved it as well. Very curious proof to know, because everyone thinks like how it's come. Someone write like directly, but you have the core. I give the core knowledge like how to prove it and how it's come and all, right? So okay, so and then I use the valid estimation which apply on when function is our decreasing, and then I use it and we get to the final flow. Okay, so that's all for today's, guys. In tomorrow's lecture, we are gonna prove some proof more and estimate more problem, because today is the theory based classes, right? We actually uh, see only one implementation here, like how to prove it. It's like when the function is decreasing and all. So in tomorrow's class, we learn more implementation, like how to estimate the definite integration. And one more thing, in tomorrow class, we learn estimation of function. This is actually important. And then we deal with the area. So these are the actually application, estimation things, area thing. So these are the application of integral. Okay, so that's all for today. Thank you, guys.